Anatomy of an atmosphere. Why Storm Goretti is bombarding the UK with 90 miles per hour winds. If you look at the weather maps this week, the UK looks less like a tranquil island and more like a target in a wind tunnel. With Storm Goretti delivering 90 miles per hour gusts to Cornwall and the Scilly Isles, many are asking, how does the air physically get that fast? To understand the science of these superwinds, imagine we have a digital telestrator, the kind used by sports pundits to draw directly onto the atmosphere. Here is the play-by-play of how a multi-hazard storm is born. 1. The engine, the jet stream power-up. The first thing we would circle on our map is a ribbon of fast-moving air 30,000 feet above the Atlantic, the jet stream. Usually, the jet stream is a steady conveyor belt. However, this week, a massive contrast between freezing Arctic air and unseasonably warm air from the mid-Atlantic has supercharged the belt. This temperature gradient creates a steep pressure slope. Air wants to move from high to low pressure as fast as possible. The steeper the slope, the faster the slide. 2. The spiral, rapid cyclogenesis, the weather bomb. As Goretti moved toward the UK, it underwent rapid cyclogenesis. In our telestrator view, we draw a tight, spiraling arrow pointing toward the center of the storm. When the central pressure of a storm drops by more than 24 millibars in 24 hours, it's known as a weather bomb. As the pressure at the center plummets, the surrounding air rushes in to fill the void. Because of the Coriolis effect, caused by the Earth's rotation, this air doesn't move in a straight line. It spirals inward, tightening like a figure skater pulling in their arms to spin faster. 3. The sting jet, the 90 miles per hour culprit. The most dangerous part of Storm Goretti, the part hitting the southwest right now, is a phenomenon called a sting jet. On our screen, we would highlight a small area on the southern edge of the storm's comma-shaped cloud head. Here, high-altitude winds are forced downward. As this air descends, it evaporates moisture, which cools the air further. Cold air is denser and heavier, causing it to accelerate violently toward the ground. The result, intense, localized gusts that can exceed 90 miles per hour, capable of uprooting trees and causing structural damage. 4. The friction factor, why the coast gets hit hardest. Why is Cornwall seeing 90 miles per hour while London sees 50 miles per hour? It's all about surface roughness. The Atlantic Ocean is relatively smooth. There are no trees, skyscrapers, or hills to break the wind's momentum. As Goretti hits the coast, the wind has maximum velocity. Once it moves inland, the friction of the landscape begins to sap its energy. Though, as we've seen with the 30 centimeters snow forecast in the Midlands, that energy is often just converted into blizzard conditions.